Hello everyone, I Professor Pardeshi AR. Today we are going to discuss the topic stream sanitation of environmental engineering 2nd BE Civil. So in that first point is the thing but importance of the stream sanitation. It is very important or essential to treat the sewage before it discharged into the natural stream because the sewage having the organic matter and this organic matter can be decomposed by the bacteria and these bacteria using the water to decompose or oxidize the organic matter from the sewage. Then the bacteria using or utilizing the oxygen, then the amount of oxygen in a water goes on reducing. Okay, and it affects the whole aquatic life or aquatic system which is present in that natural stream. So it is very essential to treat the sewage before it discharge into the natural stream. So next point is nothing but self-purification of a natural stream. It having the following process in which first one is nothing but the process of sedimentation, second process of dilution, third one is nothing but the process of temperature variation, fourth one dissolved oxygen, that is DO, and last one fifth is nothing but the flow current. So let us discuss one by one procedure which is involved in the self purification process. So first process is nothing but the process of sedimentation. In that the deposition of sewage occurs at the point where the sewage is directly discharged into the natural stream and in which it can be washed out if the flow current or a flow velocity of the natural stream is very high. The second process is nothing but the dilution process in which the large amount of water is mixed with the sewage and result in it increase the dissolved oxygen, that is the concentration of oxygen in the sewage and which is helpful for the decomposition or oxidation of the organic matter by the bacteria. The third process is nothing but the process of temperature variation. Okay, temperature affect the rate of purification process. At higher temperature, bacteria get active. Okay, and these active bacteria try to increase the decompose or oxidize the organic matter which is present in the sewage. That's why the better season for the activation of bacteria is nothing but the winter season in which purification can be faster. The next process is nothing but the dissolved oxygen, that is the DO. If dissolved oxygen is directly proportional to BOD, that means the dissolved oxygen which is utilized by the microorganism or a bacteria to decompose the organic matter. That means when BOD goes on increasing, that means the demand of or amount of oxygen required for the bacteria is increasing. That means the DO goes on the decreasing. So DO is directly proportional to the BOD. Next is nothing but the flow current, when it prevents the deposition of the sludge having the high flow or a high velocity of the natural stream. Okay, if flow is low or having the very low velocity, then sedimentation occurs and due to which bacterial or algae growth is take place and in which algae produce the oxygen in a water due to the photosynthesis process. That is the fifth process of the self purification. Next point is nothing but the zones of the self purification. Okay, and these zones are depending upon the activity and reaction of the sewage with the water. In that, first zone is nothing but the degradation zone, second active decomposition zone, third one recovery zone, and last one is nothing but the clear water zone. So let us discuss step by step particular zone of the self purification. So in that, first zone is nothing but the degradation zone. Okay, it is just situated below the outfall of the sewer. When the sewage is directly discharged into the natural stream, that is the point of the degradation zone, in which the water having the dark color and its appearance is nothing but the turbid with the sludge at the bottom. In this zone, the dissolved oxygen reduces up to the 40% of the saturation level. That means the dissolved oxygen is utilized by the bacteria. That's why the depletion of the dissolved oxygen is take place up to the 40% of the saturation zone, in which the carbon dioxide percentage goes on increasing, and these conditions are not favorable for the aquatic life, in which the aquatic life cannot be survived, where the sewage is directly discharged into the natural stream. The second zone is nothing but active decomposition zone. Okay, this zone, having the water in the zone become grayish in color and dark in color, okay, than the previous zone. The dissolved oxygen concentration falls to directly 0. Okay, in this zone the dissolved oxygen amount is 0, and in which fish life is absent and bacteria is present. In this active decomposition zone, the total decomposition of organic matter take place. That's why the aquatic life or a fish life is absent in that particular zone. Okay, at the end of this zone, DO goes on rising up to the 40% of the saturation. While flowing the river, the dissolved oxygen get increase in this active decomposition zone, and it rises up to the 40% of the saturation zone. And at the end of this zone, aquatic life get appear. Third zone is nothing but the recovery zone. Okay, in this process of recovery get start, in which stabilization of organic matter take place. Okay, stabilization of organic matter take place in this recovery zone, and BOD falls and DO content goes on increasing up to the 40% value. And near the end of this recovery zone, the aquatic life get appear. This is the recovery zone. At the end of this zone, we can saw the aquatic life as well as fish life in that zone, in which dissolved oxygen concentration goes on up to the 40% of the saturation zone. And last zone is nothing but the clear water zone. Okay, the water becomes clear and attractive in the appearance. Okay, and in this zone, dissolved oxygen rises the saturation level, that is the 100% DO is present in that case, and oxygen balance is admitted in clear water zone. And this is the complete recovery, and this is the complete process of the self purification of natural stream. Okay, the chart shows the zone of purification. In that, in first column there is a dissolved oxygen sac curve, in which the saturation level having the 100% of the DO when the water is clear, and clear there is a no sludge at the bottom. When in a second zone of degradation, the dissolved oxygen goes on decreasing. Okay, and in this having the physical properties like a floating solids is there, sludge bottom is present, and having the dark color and having the turbid appearance. In the zone of the active decomposition, the dissolved oxygen goes on up to the limit 0. There is an absence of oxygen, and in which sewage having the color grayish and dark color is there, and which produces the gases like methane, hydrogen sulfate, carbon dioxide, nitrogen, and the scumming layer is formed at the surface of this sewage in this zone. Okay, the next zone is nothing but the zone of recovery, in which the dissolved oxygen goes on rising. Okay, but the water looks like a turbid with the bottom sludge. And in a last zone, that is the clear water zone, the dissolved oxygen goes on rising up to the level of saturation level, that is the 100% DO is there. Then the water looks like a clear water, and there is a no sludge form at the bottom. Okay, next point is nothing but the factors affecting the properties of the self purification of the stream. Okay, in that first one is nothing but the flow current. Okay, if a natural stream having the high velocity flow, then there is a no deposition of the sludge at the bottom or a bed of the natural stream, which is resulting the self purification process. Second factor is nothing but the dilution. Dilution means what? The sewage is get diluted with a large amount of water, which increases the dissolved oxygen in the water, which helps in a self purification process. Third one factor is nothing but the sunlight. It is very important factor in which the algae by the process of photosynthesis release the oxygen in the water, and which is helps to the purification process of a natural stream. Next factor is nothing but the rate of oxidation. It increases with the organic matter. Okay, oxidation is increasing with the organic matter present in the sewage, because the bacteria decompose or oxidize the organic matter which is present in the sewage. And last factor is nothing but temperature, in which dissolved oxygen is depends on the temperature. Okay, if temperature rises, dissolved oxygen goes on decreasing. That's why winter season is a better season for the cell purification process. These are some factors which affect the cell purification of the natural stream. So next point is nothing but the oxygen sac curve or dissolved oxygen sac curve. We can saw in a diagram that is a saturation concentration zone, that is having the 100% dissolved oxygen is there. There is a dotted line shows the decreasing amount of biochemical oxygen demand while the flowing or a downstream side of the natural stream, and at a particular point DO is minimum, that is the active decomposition zone where the dissolved oxygen is minimum, and while flowing of the river or a natural stream it goes on increasing, that is known as dissolved oxygen sac curve. Okay, in that two concepts are very important. In that first concept is nothing but deoxygenation curve. Okay, when the pollutional load is discharged into the natural stream, that time the DO, that is dissolved oxygen, goes on reducing. That process is known as the deoxygenation. That means when we discharge the sewage into the natural stream, what happens? The bacteria present in a sewage utilize the dissolved oxygen from the water to decompose the organic matter which is present in the sewage, and dissolved oxygen goes on decreasing. That is nothing but the deoxygenation, and it is depend upon the organic matter which is present in that sewage and temperature. The variation or depletion or reduction of the dissolved oxygen represented graphically is known as deoxygenation curve. And second concept is nothing but reoxygenation curve. At the same time, oxygen get added into the stream through the various process such as photosynthesis, rains, up and down of the natural stream, due to which the atmospheric oxygen is introduced in a natural stream, which is increase the dissolved oxygen quantity in that particular stream. The curve representing oxygen gaining or a rising process is known as reoxygenation or a re-aeration curve, in which the amount of oxygen is increasing in a natural stream. In a running polluted stream, deoxygenation and re-aeration process go hand in hand. These two processes are continuously or simultaneously occurs in a natural stream. Okay, this is the chart shows the reoxygenation and deoxygenation as well as oxygen sac curve. Okay, on a x-axis we can saw the time of flow of natural stream. On a y-axis dissolved oxygen content is there. That is in that first saturation DO having the 100% dissolved oxygen is there. Then what happens when sewage is discharged into the natural stream? It goes on decreasing, that is the deoxygenation curve. And while the flowing of the river with the time, the oxygen is introduced in the natural stream. That is concept is known as the reoxygenation curve. Okay, the amount of dissolved oxygen deficit can be obtained by graphically adding both the curve, that is reoxygenation curve and deoxygenation curve, and the resultant curve is known as dissolved oxygen sac curve. Okay, and the DO deficit it can be given by the formula by using the saturation DO minus actual DO. Okay, from which we can calculate the DO deficit. Okay, so thank you. Next part will be continue in a next lecture. So thank you.